First of all, blood pressure is defined as the pressure that the blood exerts on that artery wall. So when the blood pressure cuff is around someone's arm, we can blow up the cuff and release the cuff, and we can determine the pressure of each pulsation that is felt in that artery and determine what that pressure of that pulsation is. We'll get to this later, but the blood pressure is also calculated by cardiac output times the peripheral vascular resistance. I put that on here, but we'll bring it together at the end. So some important terms that you need to know are cardiac output. We just talked about that. Stroke volume, preload, and afterload. And we're going to discuss each one of these. Cardiac output is the amount of blood that is pumped each minute from the heart. So if you could gather the blood that was pumped out of the blood for a total of 60 seconds, for a total of 1 minute, how much blood would you have there? So the stroke volume is the amount of blood that is pumped with each heartbeat. So how much blood is leaving that left ventricle going into that aorta with each pump of that left ventricle? That times we have to decide in a minute's time. So how many beats does the heart beat in a minute? So we take the heart rate, and we talked about that in a previous section, times how much blood is ejected in one pump of the heart. And the only way that we can determine this is by having an internal monitor. You cannot determine this by blood pressure, by taking someone's pulse, but they would need to have an internal monitor into a major vessel and be in the ICU so we could measure that. So it would be the patient's heart rate times how much is pumped out in each pump. And that would give you the volume over a minute. So, for example, if the internal monitor is telling us that 80 milliliters of blood is being pumped out with each squeeze of that left ventricle, and there's 80 heartbeats per minute, how much would that patient's stroke volume be? All you would do, like we had in the previous slide, would be the beats per minute times the stroke volume. So it'd be 80 times 80. That'd be 6,400 milliliters, which is 6.4 liters. That's a lot of blood that seems to be pumped in a minute. And the normal amount of blood pumped in a normal person's body is 5 to 7 liters. So we're right there, aren't we? At 6.4 liters. So an average heart rate could be 80 beats per minute. That's normal. And 80 milliliters of blood with each pump of the heart is normal. So 6.4 liters is a normal amount. So 2 terms, preload and afterload, you're really going to talk about more in pathophysiology. But to put it simply, the preload is the relaxation of those ventricles to allow blood to fill up. It would be like taking a balloon and filling it up with water. If the balloon is relaxed and there's no pressure there, then you can put a good bit of water in a balloon, right? But if you've got the balloon in your hand and you're squeezing the balloon and then you're trying to put water in it, not much water is going to go into that balloon. So we need to have a large amount of preload. We want to have a large amount of blood in that ventricle. So think about it. We want to have a large amount of water in that balloon because we want to be able to squeeze it out when, we throw the balloon or whatever. We want to be able to have a lot of water there. That's what makes it more fun. But when the heart is relaxed, we want a good bit of blood in that ventricle. And then that is the preload. And then the afterload is not the amount that's given out, but the resistance that the vessels give that blood when it's pumped out. So let's just say that you have a balloon and you've got it still tied off, and you try to squeeze that balloon for water to squirt out, nothing's going to squirt out because there's resistance. We don't want that because we need our body to get plenty of oxygen. So we need to untie it, right? So we need to untie it so that you can easily squeeze the balloon and water comes out. So the afterload, we want to have a little amount as possible resistance so that all that blood leaving the ventricle can pump out with such great ease. So we're going to talk a little bit about measuring the blood pressure. And you've had your blood pressure probably taken electronically like that on the left picture, or with a stethoscope at the doctor's office. But either way, you have a top number.
Here's what I found.
And a bottom number. So if you have, this particular patient has a top number, which is a systolic number, as 150, and a bottom number is a diastolic number. And we're going to talk about what those two numbers mean. Oh, and then the 77 is just that person's heart rate. And is 77 normal? You tell me. So systolic goes over the diastolic, and the normal is around 120 for a systolic top number, and the normal is about 80 over the bottom number. So the top number lets us know the number is the pressure of the blood when pumped into the arteries. That's what it's like. If you were to think of a heartbeat, it would be at the peak of that beat, at that beat. The diastolic number is when it's relaxed. That would be like in between the heartbeats. So your systolic is the pressure of blood when pumped into the arteries, and the diastolic pressure is the relaxed state when the blood is filling up in the ventricles again. And we're hoping that the preload is a lot, right? We want blood to fill up really good in those ventricles. This slide gives you something to look at. You know that what those numbers are, 120 over 80, you know that that's your magic numbers, but it can fluctuate from person to person. But hypertension is when that number is greater than around 140, and the bottom number is greater than 100. And there are certain factors that can cause a person to have elevated blood pressure. And those could be obesity, ethnicity or gender, which we know males have more high blood pressure than females. So lack of physical activity, we're not exercising enough, smoking, too much intake of salt, caffeine, alcohol, stress, and anxiety. I mean, how many times have we heard, oh my goodness, it's going to make my blood pressure go up. I'm so stressed out. And age. So the older we get, the less elastic our vessels are. So it can affect our blood pressure. So high blood pressure is defined as a systolic blood pressure, that's the one on the top, that's greater than 140, and the diastolic blood pressure, the one on the bottom, that's greater than 90. It can be acute or chronic, and you're going to hear acute and chronic in your patho class a lot. Acute means when it suddenly happens. Oh my goodness, you just heard a loud boom, like something popping, like a balloon popping, and you jumped and your blood pressure shot up. That's acute. Chronic is when it happens over a long period of time. It could be months, it could be years, or a lifetime that someone has increased blood pressure. And then hypotension, which is low blood pressure, results when the pressure is less than normal. Now, the causes of hypotension could be loss of blood, the less blood and circulating volume we have in our body, the lower our blood pressure will be. It could be certain medications, such as digitalis or digoxin, and other reasons that result in hypovolemia, like, for example, if someone has a major injury and they're bleeding blood out, or they're having profuse diarrhea or vomiting and they get dehydrated, your blood pressure will go down. Okay, that's the end of the slides, and you can move on to the next module.